These are additional problems for dilution problems. So let's do number one. What is the molarity of a solution of ammonium chloride prepared by diluting 50 milliliters of a 3.79 molar ammonium chloride solution to 2 liters? So that means that we used a certain amount of water, and for our purposes it doesn't really matter, but we can figure it out. 2 liters minus 0.05, that should give us 1.95 liters of water. So in order to figure out the molarity of this final solution, we need another piece of information. We need to know how many moles are in here. Now, if we can figure out how many moles are in this first solution, we can automatically figure out how many moles are in the final solution, because it wouldn't have come from the H2O. It doesn't contribute anything in terms of moles or molarity. Now we need to figure out how many moles are in that first solution. So we have 3.79 molar, which means that another way to write that down is 3.79 moles per 1 liter. But we don't have 1 liter of it. We have 0.05 liters of it. So we need to solve for the amount of moles that we have in 0.05 worth of that much molar. So we can just multiply 1 by 0.05, and if we were to do the same to 3.79, we should get 0.18 moles. So that means these moles are in 0.05 liters worth, and if we dump that whole thing into here, then that's how many are here as well. So now we know the moles, and we know how much we have, 2 liters. So let's write out a for every statement of what is in this solution. So for every 0.18 moles, there are 2 liters. We need to figure out what the molarity is, however. And molarity can be known when the for every statement ends with 1 liter. But it doesn't end with 1 liter right now because we have 2 liters worth of it. So we need to divide by 2. And whatever we do there, we have to do there. And what we should get is 0.094. So this for every statement, because it ends in the 1 liter, this is actually the molarity. So the molarity of that solution is 0.094. Number 2. A student takes a sample of KOH solution that is 0.1 liter. The student determines that the diluted solution is 0.046 molar, but has forgotten to record the volume of the final solution. The concentration of the original solution is 2.09 molar. What was the volume of the final? So they didn't tell us how much water was used, and they're trying to ask how much of this final solution we have. Once again, if we know the molarity, that it's 2.09, that means that there is 2.09 moles per 1 liter. We don't have 1 liter, however, we have 0.1 liter. So we multiply both sides times 0.1, and what we should get is 0.209 moles in 0.1 liters worth of it. So if we use this solution to pour in there, then we know exactly how many moles are there. If we know the number of moles, then we can figure out how much volume we have. So first, let's write out our molarity as a for every statement. So for every 0.046 moles, there are 1 liter. Right now we don't know how much we have in terms of liters, but we do know the moles. We don't have 0.046, we have 0.209 moles. In going from 0.046 to 0.209, we divide by 0.22, If we do the same to the 1 liter, we get 4.5 liters. So that final volume is 4.5 liters of that diluted amount. And that makes sense, because when you look at the molarity, you're starting with 2.09, and it's going down not just to 1, not just to 0.1, but to 0.04 molar. So that means we have to have a lot more than 0.1 liter, because we're watering it down a lot. And then the final problem on the extra practice. To what volume should 1.19 milliliters of an 8 molar, so we have 8 molar, and 1.19 milliliters should be 0.00119 liters. So we're working with a very small quantity. How much of that, to what volume should that solution be diluted in order to obtain a final solution? That is 1.50 molar. So we're starting with very little of a high concentration, high molarity solution, and we want to end up with something that's a lot less, a fraction of the molarity, and we're trying to figure out what it should be diluted to. So that means the number of liters should go up, because as the liters goes up, the molarity goes down. Same logic, we have to find the number of moles. If we find the number of moles, we know how much are in there, and based off the molarity and the number of moles, we can figure out the volume. So first, a for every statement with the 8 molar. For every 8 moles, there are 1 liter. We don't have 1 liter's worth of it, however. We have very little, 0.00119 liters worth. In finding the conversion factor, you figure out that 1 has to be divided by 840, or multiplied by whatever this is, to get that number. And what we find is there are 0.0095 moles in this thing right here. That means this thing went here. And that's how many moles there are. So we know the molarity. For every 1.50 moles, there are 1 liter. We don't have 1.50 moles, however. We have very little, 0.0095 moles. So what we find is that in order to get from 1.50 moles to 0.0095 moles, we have to divide by 157. If you do the same for the 1, you get 0.006 liters. So what we started out with was 0.001 liters worth, and we ended up with 0.006 liters worth. So we're starting with very little, and we're also ending with very little, but that's how much we would end up with if we went from 8 molar to 1.5 molar. And it makes sense because you're not dividing by a huge fraction, so the number of liters should stay close enough.